Hello, my dear students. Very welcome to all of you in your physics class. We are talking about rotational motion. All concept of rotational motion, all parameters of rotational motion we have understood. Kinetic energy. Especially in this lecture, we are talking about the kinetic energy, and same kinetic energy for rotational motion and translatory motion we can use in conservation of energy also. Okay, so how we can use concept of rotational kinetic energy in conservation of energy in this lecture we have to see. So we are talking about law of conservation of energy for rotational motion. Okay, let's see an example. Okay, how this law of conservation of energy we will use: initial potential energy of system plus initial kinetic energy for rotational motion plus initial kinetic energy for translatory motion is equal to final potential energy plus final kinetic energy for rotational motion plus final kinetic energy for translatory motion. Okay, so whenever we are talking about the conservation of energy, we have to take rotational kinetic energy plus translatory kinetic energy both in consideration. Okay, let's see how. Let us consider a circular body. Okay, a circular body. This circular body may be ring, may be hollow cylinder. Okay, may be circular disc, solid cylinder, a spherical shell, or solid sphere. Okay, so if this circular body is rolling down on inclined plane, let us consider the height, initial height of the center of mass of this circular body is h. Okay, so if this circular body is rolling down, it will gain rotational kinetic energy as well as translatory kinetic energy. Okay, the potential energy, since it is initial kinetic energy, is equal to 0. Its initial kinetic energy is equal to 0, and at the bottom let us consider the velocity v and angular velocity is omega. Okay, so all potential energy will convert into the translatory kinetic energy plus rotational kinetic energy. So we can use here conservation of energy. Initial potential energy is mgh plus initial kinetic energy for rotational motion, it is equal to 0. Initial kinetic energy for translatory motion, it is also equal to 0. Final potential energy, when it reaches up to the ground, so the potential energy will become 0. Now final kinetic energy is half I omega square if this body is rotating with omega at the bottom, plus 1 by 2 mv square. V is the velocity of center of mass. Velocity of center of mass. Okay, so this mgh is equal to 1 by 2 I omega square plus 1 by 2 mv square. Okay, if this body is performing pivot rolling, if we are talking about pivot rolling means there is no sliding between inclined plane and a spherical or circular body. Okay, what is meaning of pivot rolling? No sliding. Okay, so in this case what we can write, this v can written as omega r, this v can written as omega r. Okay, so this mgh is equal to 1 by 2 I, this omega can written as v by r whole square. This if v is equal to omega r, so omega is equal to v by r. Okay, plus 1 by 2 mv square. From this equation we can find value of v. What is v? V square is equal to 2mgh divided by I by r square plus m. Okay, so v is equal to root 2mgh divided by I by r square plus m. Okay, this is the velocity at the ball. So we are getting velocity v is equal to root 2mgh divided by I by r square plus m. Okay, this moment of inertia I we can written as mk square. What is this k? What is this k? It is the radius of gyration. It is the radius of gyration. Okay, so this velocity now we can write 2mgh divided by what this I can written as mk square. So mk square by r square plus m. Now what we can do? We can cancel m. So this velocity can be written as 2mgh. 2mgh. Oh, m will cancel out. Okay, so it is 2gh divided by 1 plus k square by r square. Okay, so it is the concept. Okay.